asymptote, for a horizontal asymptote, this is something that will go on your note card, by the way. What we're about to write, you can put on your note card. No math can go on your note card. No examples worked out, nothing like that. But the rules can go on your note card, how to determine them. So what we're about to write can be on this, okay? So let's say that you have some function with a numerator and a denominator. I'm going to call the numerator n and the denominator m, okay? So we've got three cases here. Oh, no cursive, sorry. If the degree of n is less than the degree of m. What does degree mean, by the way? The highest exponent, exactly. Okay, so if the highest exponent on the top is smaller than the highest exponent on the bottom, that's what that's saying, okay? If the degree of n is less than the degree of m, then there's a horizontal asymptote at y equals 0. HA, horizontal asymptote. It's a really long word. It's a long time to write. We're going to call it HA. Alright? Alright. There's just a little example. See? Degree of the numerator is 2. The degree of the denominator is 3. The degree of the top is less than the degree of the bottom. Then there's a horizontal asymptote at y equals 0. Okay? Basically, that's the x-axis. Alright? If the degree of n is equal to the degree of m, then the horizontal asymptote is y equals the lead coefficient of n over the lead coefficient of m. What is a lead coefficient? The number in front, right, okay? So if I have f of x equals 2x squared plus 3x minus 9 over 5x squared, 7x. Those two have equal degree, right? They're both squared, squared and squared. So this horizontal asymptote would be at y equals 2/5. Right? This is y equals 0. Something I want you to notice, y equals, y equals. Horizontal lines are y equals, vertical lines are x equals. When we're taking our quiz or test or whatever over this, and you're asked what is the vertical asymptote, what's the horizontal asymptote, you can't just put the number. Oh, it's 2, it's 7, it's 8. Because I need to know that you know Vertical asymptotes are x equals because they go up and down, that's x equals. And horizontal asymptotes are y equals because they are flat and horizontal. Okay, so you have to put that in. Alright, so we have a less than, we have an equal to, guess what else we have? Greater than. If the degree of n is greater than the degree of m, there is no horizontal asymptote. This is another one to watch out for on a test because it may not have a horizontal asymptote. You have to put no, none, not one, doesn't exist, something. Don't leave it blank because if you leave it blank, I don't know. Hey, do they realize that there's not one? Or do they have no idea what I'm talking about, so they skipped it? Okay?
Usually option B with me.
Exactly, right? So, you have to put something there. And don't put 0, because what is 0 going to make me think? Right, exactly. So, you have to put the words none, no, not one, whatever. So, let's say you've got f of x equals 2x to the third over x minus 6. Okay? See? What's the degree of the numerator? What's the degree of the denominator? 1. So there is no horizontal asymptote. Alright? Got this written? Move this. So right. So I'm going to give you 3 examples for you to figure out. How about f of x?
0.
Y equals 0. G of x?
No, it's
Y equals 0.
Wait,
Well, what is it?
that's 9.
Y equals 0 because n is less than.
Oh, it's 5.
Look, look.
2 is less than 3.
2 is less than 3. N is less than m.
Y equals 0.
Yes.
And that is
5 equals
5, 9.
All right. Wonderful. What? Okay. So those are horizontal asymptotes. Yes.
We're going to.
All
I'm
right.
not going to judge you by your nose.
No.
Let's talk about slant asymptotes. I am. Okay, so vertical asymptotes are vertical. Horizontal asymptotes are horizontal. Guess what? Slant. I bet they slant. They're slanted. Yeah. Okay. So So slant asymptotes don't always occur. Slant asymptotes don't always occur. We have a slant asymptote. Yeah. If the degree I'm scrolling off. If the degree of the numerator is exactly, okay, one more than the degree of the denominator. Can you have a, it's not denominator 4, very well. Can you have a slant asymptote and a horizontal asymptote in the same problem?
Yes.
Alright, what's the rule here?
One more
So yeah.
If the degree of the top is exactly one more, then the degree
Which means n is greater than m.
Yep.
but by one.
No, because that would be That would be 9.
Right. If n is greater than m, there's no horizontal asymptote. So you can't have a horizontal and slant in the same problem. Okay? Can't have it. Now, if the numerator is like y equals x to the 12th, and the denominator is y equals x squared, no. Okay? It has to be exactly one more. So how do we find out what it is? You're going to love this part.
As in, it's like
Long division.
Yes.
awesome. Yes.
Oh, since you explained long division, I bit my tongue talking.
That's homeschool folks that email me that they watch it.
Really? School is so wonderful.
Yeah.
Who is this teacher?
Hello.
It's not super bad though, the long division, but it does have to be long division. You can't use synthetic.
I wonder if like some homeschool kids can listen to that. Maybe fake gay. Just threw up back there. There's no throwing up in here.
Yeah, you're not allowed to throw up in here.
There's no puking.
No puking is
We're
allowed.
not allowed to pass out either.
Or bleed, or
Nobody bleeds.
yeah. He broke two because he bled and then passed out because he saw it. So he broke two floors. He paid the price.
Can I throw up?
Unfortunately, so did my refrigerator.
Yes, that's the day.
Wasn't he pierced his ear?
Alright, yes.
I remember sitting in Mr.
Okay.
Carter's and all you hear is
Yes. Alright, so numerator is 3, denominator is 2. Okay, so that's one more. So we have to use long division. Can't do synthetic with a quadratic.
Oh, I was saying I can't do long division, but I can do some.
Oh, okay. How many times does x squared go into 2x cubed? 2x times. So that's going to be 2x cubed plus 2x squared plus 6x. And then what do you do with this bottom row?
You switch the
switch
sides.
sides.
Yes, change all the signs. What times x squared gets you 3x squared? 3. Alright, it's okay. Because here's the good news, okay? Hang on one second. once you know that these cancel out, you're good, because we don't care about the remainder. The slant asymptote is this right here. Yeah, we're just halfway doing it, like most of you do your homework. I don't care. Because my slant asymptote is this part right here. It's not the remainder. The 9x and all that, that's the remainder, and I don't care about the remainder. Alright, do you remember how to graph this? 2x plus 3. Where do you start? Y equals 2x plus 3. Where do you start? At 3. And then what happens?
You go over 2 and up 2?
No, you go up 2 over 1. That would be your slant asymptote.
And then down 2 over 1?
No, you just need 2 points to make a line. Yeah. So that's how you do a slant asymptote. How to graph it? You start with your y-intercept of 3, and you go up 3 and make a point. And then this is your slope, 2 over 1. So you go up 2 over 1, make another point, and connect the points. Okay? We are not going to graph today. We're going to find all the stuff associated with the graph. Okay? So there will be no graphing today. If you look at your page from yesterday,